general solution. So for sine, you're going to have two general solutions, right? I also did a similar video last week, so I'd also recommend you go and look at that video to explain why we're using two general solutions, okay? For sine, remember, it is, sorry, I just want to sketch it quickly. So your sine graph looks like that, right? So let's say they want you to solve sine theta is equal to a half. A half would be somewhere there. Now, if I go and do this, right? Look at how many solutions you're going to get between 0 and 360, right? You're going to get a solution here. This is one solution, and you're going to get another solution here. So x1, x2. Okay, so that's why we have two solutions. It's going to be, the first one is inverse sine m, and then the second one is 180 minus inverse sine m. Because you also get two general solutions. Now remember the graph for your cos, it's similar to sine, but the difference now is that it starts at 1 and then it goes down like that and all the way up, right? Okay, so it's going to look like that. So let's say again, we're looking for half. So if that's your half there, look at the solutions you're going to get. You're going to first get a solution here. Okay, that will be the first solution. Now remember, your cos also extends this way. Okay, so the other solution you're going to get is here. Okay, now look, this side is positive x, right? Now this side is negative x. So that's why you have plus cos inverse m and minus cos inverse m. Okay, so that's where the plus and the minus comes from for your cos. Now your tan is the only one that's going to have one general solution. Now, the only thing different is that for your cos and your sine graphs, the period is 360. For tan, however, it's 180. Okay. Right, let's look at this first one. So if they want us to determine the general solution of the following, so you have 2 cos theta is equal to negative 1.
Excuse me, ma'am.
Yeah.
Sorry to disturb, ma'am. Can ma'am quickly go to the previous? I just want to see that slide, please, ma'am.
Okay, this one.
Okay, thank you, ma'am. Ma'am can scroll down again.
Okay. So we want to determine the general solution of the following. 2 cos theta is equal to negative 1. So for us to do this, we know that we're going to use the two general solutions for cos. Before we do that, remember, you always want to isolate for theta. Okay, in doing that, we're going to do inverse operations. So what's the first thing that I should do here? You have 2 cos theta is equal to negative 1. Before I can say inverse cos both sides, I'm going to have to divide both sides by 2, like that. So you end up with cos theta is equal to negative a half. Then when you're at this point, that's when you can now do your inverse cos both sides. So inverse cos of your negative a half, right? Plus 360 degrees K, and K is an integer. Remember we said 360 because that's your complete wavelength or your complete period. There's something I've left out here. For cos, remember we have plus or minus. Okay, so let's go ahead. Inverse cos both sides. Very important. If you're in your test or your exam, always make sure that your calculator is in degrees, not in radians or gradients. Okay, otherwise all your answers are going to be wrong. So inverse cos negative a half. So I get theta is equal to 120 degrees. Now remember, it's plus minus 120 degrees plus 360 degrees K. K is an integer. So you can write it like that with the plus minus. Other people write two different ones. So they're going to have 120 degrees there, 360 degrees K, or negative 120 plus 360 degrees K. And remember, K is an integer. Okay, so these would be our general solutions. So you can write it like that, or you can write it with a plus minus. Okay, all
Excuse me,
right.
ma'am.
Yes, Laura.
Ma'am, I wanted to ask, is k just a variable that comes with 360, or is it like a specific number?
So it's a variable, but it's an integer. Okay, so k is the variable. When we're now looking for the actual values of what theta are, which is what we're going to do after this, that's when we're going to start plugging in values for k. So k is an integer. So we're going to plug in k is equal to 0, then k is equal to 1 or -1, or k is equal to 2 or -2. Okay, and then at some point we're going to stop based on the interval they give us. But I'm going to look at that after these two questions. Okay.
Okay, thank you, ma'am.
Awesome. Mo?
Ma'am,
Yeah.
another question I wanted to ask. Say, for instance, they give us a domain. Are we going to do that later also, or examples?
So like a domain, what do you mean exactly?
Ma'am, when I give you a domain like -180 and 180,
Oh,
you
yes.
must have salute. Are we going to do that also later, ma'am?
Yes, that's what's coming.
Okay.
So that's also what Laura was just asking. So you're asking the
okay.
questions. Yeah.
Okay. Sorry, ma'am.
No problem. It's fine. Okay. Then number 2, right? This is now 2 tan open brackets 2 theta minus 10 degrees is equal to 4. Okay. So anything that's inside the bracket, you're going to do at the very end. Okay. After you've taken your inverse tan. For this one, first things first, you start with the outermost term, divide both sides by 2 because you want to isolate for theta. So once we've done that, we're at the point where we have tan, open brackets, your 2 theta minus 10 degrees is equal to 2, right? Remember I said anything in the brackets, we're going to deal with that at the very end. So now with this one, inverse tan both sides. Let's go ahead and do that. When you do that, you're going to be left with 2 theta minus 10 degrees is equal to inverse tan 2. Okay, so what's inverse tan 2? It is 63,43, right? So this is plus your, so remember for tan, it's not 360, it's going to be 180 degrees K. K is an integer. Okay, so 63,43 degrees plus 180 degrees K. K is an integer. Now, remember, you still have your 2 theta here and your minus 10 degrees. Okay, balancing method or inverse operations. Okay, we haven't isolated theta. We still have to take that -10 degrees over to the other side. So it was -10, it's now going to be plus 10. So if I add 10 to both sides, it becomes 73,43 degrees plus 180 K. Now, here you're left with 2 theta. Okay, very important at this point. This 2 theta, you want to isolate theta, that means you have to divide everything here by 2, like that. Okay, so this is now theta is equal to, let's divide that by 2. I get, sorry, 36,71 degrees plus 90 degrees K, and K is an integer. Okay, right, and that would be your general solution for this particular
Excuse me,
question. Yeah.
Do you always need to write at the end of like your sum k is an element of integers?
Yes, so you can write it at the very end. So like at this point here, you don't have to include them there, but as long as at the end you have shown that K is an integer. Okay.
Okay, thank
All
you,
right.
ma'am.
Cool.
Hey, ma'am.
Yeah.
Ma'am, why do we divide everything like the 180K also by
Okay.
2?
Okay, so now for this one, this particular graph, right? It wasn't theta, it was 2 theta, okay? Meaning that your period is going to be shorter or smaller. So remember your tan graph looks something like this, right? And then you have asymptotes. Okay, it will start off there. Okay, it has asymptotes after every 180. But whenever you multiply the theta by 2, it reduces the period. So the period also has to be divided by 2. Okay.
Oh, okay.
Yeah.
That's right.
All right.
Thank you.
Sure. No problem. Okay. So now we're now going into the questions that Laura and Mo asked earlier. Can you see now they've given you an interval? With this interval, what they're asking us to do, they want us to solve the actual question and find actual values of theta, not just your general solution, but actual values of theta. Okay, so first things first, you do what we did previously with the cos and the tan. First, find your general solution. Then that's when we're going to select values of k, okay, from which is an integer, integers 0, 1, 2, or 0, -1, -2, okay. All the answers that we get have to fall within this interval. Any answer that's outside that interval, we're not going to put as our final answer. Okay, so let's go ahead. Let's first find our general solution. So sine theta is equal to -1/5. Okay, inverse sine both sides. Okay, -1/5 plus 360 degrees k, and k is an integer, right? That's your first one. Then your second one, theta, 180 degrees minus your inverse sine, -1/5 plus 360 degrees k. K is an integer. Okay, now let's find the actual value here. -1/5 inverse sine. This, what I get, okay, so for the first one, this is going to be -11,544 degrees plus 360 degrees k. Then remember, you have to then say for the second one, 180 minus whatever you got there. So 180 degrees minus 11,544 degrees plus your 360 degrees k. Okay, k is an integer. Okay, so the first one doesn't change. The first one stays as -11,544 degrees plus 360 degrees k. The second one, however, is now 180 plus, okay, which now gives us 191,54 degrees plus 360 degrees k. Okay, k is an integer. Now, if they had just asked us to work out what the general solution was, we would leave our answers like this. What we have to do now is now test or sub in values of k. Sub in values of k. So what's the easiest one we can start off with? Let's start off with k equals 0. Okay. You're going to plug them into your equation 1 and into your equation 2. Okay. So where you see k, that's where you're putting 0. So for the first answers, okay, your first theta is like this. So I'm doing all the steps so you can see where I'm plugging in the 0. Okay, so that's our first integer we're plugging in. So our answer for this one is going to be -11,54 degrees. That's our first answer. Now, is this value that we found, is it within the interval range -360 degrees and 360? Does it fall within this range? Yes, okay, it's on the number line, it's in between. Okay, so basically what this is a number line, okay, starting from -360 all the way up to +360. That means that -11,54 is going to be somewhere here, okay, if your 0 is there. Okay, so this is going to be part of our solutions, or it's going to be one of our answers. Then the second one, 191,54 degrees plus 360, and our k, remember, is 0. So our second value, 191,54 degrees. Does this value fall within our interval? Okay, let's see. Yes, it does. So this one is somewhere here, 191,54. Okay, so we're going to keep that one as well. Now, since we've tested k is equal to 0, let's test k equals 1. You're going to do the same thing, plug it into the first equation. It's 360 multiplied by 1. Okay, so now at this point, okay, so 360 minus your 11,54, the answer you get there is 348,46. That's a theta. Is this theta inside our range? Yes, it is, because it's going to be somewhere there. 348,46. Okay, now we're plugging into the second one. Okay, so the second one now, 191,54 degrees plus 360 multiplied by 1. Right, what's your answer going to be for this one? Okay, I get 551,54. Now, is this value, okay, it within this range here, within this interval? Yes or no? What do you guys think?
No.
No. So we cannot take that value. This is not going to be within that range. Does it make sense for me to go and try k equals 2 here? If I try k equals 2, are any of my values going to be in the interval?
No.
No, ma'am.
Perfect. No need to try k equals 2. So since we've tried k is equals 0, we've tried k equals 1, there's no need to try k equals 2. But we can try k equals negative 1. Right. Let's go ahead and do that. Okay. So theta equals 154 degrees plus 360 multiplied by negative 1. Okay, now here, what you're going to get is negative 371,54. Is this value within the range negative 360 to 360? Should I take this answer or should I discard it?
Discard.
Perfect. So I'm not going to use that one. So let's try in the second equation now. 191,54 degrees plus 360 multiplied by negative 1. Okay, so 191. I get negative 168,46 degrees. Is this value within my range? What do you guys think?
Yes, ma'am.
Perfect. Okay, this one is within my range. Do you think there's a need for me to try k is equal to negative 2? What do you guys think?
No, ma'am.
Okay.
I don't think so.
All right, good. So now when I'm listing all my solutions, okay, I'm going to go from descending or the smallest. Okay, so smallest to largest. Okay, so the smallest one is so the thetas that I'm using, okay, negative 168,46. Then we had negative 11,54. Then we had 191,54 and 348,46 degrees. Okay, don't forget to add your degrees there. Okay, so those are our 1, 2, 3, 4 solutions. Okay, so can you see how you always start off with your general solution, then you go try values of k. So starting from 0, 1, 2, 0, -1, -2. Okay, does this make more sense?
Yes, ma'am.
Yes,
But ma'am,
ma'am.
I have a question.
Yeah.
Ma'am, from the start of like the solution, does ma'am mind like scrolling up,
Okay, yeah.
like all the way from the start? I
Yeah.
wanted to ask, why did ma'am say 180 minus sine? Like,
Oh, okay. So now remember your for sine, right? Your sine always has two solutions. Okay. The first one is the normal inverse sine, whatever the value was, plus 360k. Okay. Then the second one is 180 minus inverse sine. This is the second solution. Now, if I take this onto my cost diagram, right now, remember, all students take care. That's your cost diagram. All of them are positive in the first quadrant, but only sine is positive in the second quadrant. So that's why it's 180 minus, because any thing in the second quadrant is always going to be 180 minus whatever theta is. That's why it's 180 minus. Okay. So that's why we take
Okay.
those ones. Okay. So you can also extend the cost diagram to cos, right? So for cos, you see it's going to be in the first quadrant and the fourth quadrant.
fourth.
Right. There are two ways of getting to the first quadrant and the fourth quadrant. So this one is straightforward. Okay. It's just going to be going anti-clockwise, and that will be your theta. Now, the other way of going to the fourth quadrant is going clockwise. Instead of counting it as theta, now this value is going to be minus theta. So that's why for cos, you have a plus and a minus. Okay.
Yes, ma'am. Thank you, ma'am.
Sure. All right. Okay. Does anyone have, so we have about, it's going to be 13 minutes. Is there anything else that you guys want us to do? Or would you like me to do another question that looks like the one we just did?
Ma'am,
Yes.
I just have a question on the last
Mhm.
one we did, the example. Do we have
Yeah.
to give all that answers for theta, ma'am?
Yes, so you can't just give one, because remember the question was they want all values of theta which are between the range -360 degrees up to 360. So you have to show all four solutions. Okay.
Okay.
Awesome.
Ma'am, and the numbers that we use,
Uh-huh.
must it always be 0, 1, and 2, or can it be -1, 0, and 1?
So you're always going to test them, right? So the easiest one to test is always start off with k is equal to 0. Then you
Okay.
test k equals 1, then you test your k equals 2. Check to see if all the values you get are within whatever range they give you. Okay, so once you hit a dead end with the positive integers, you're now going to then go and try k equals -1. Then you try k equals -2. Sometimes, okay, you can even go up to k equals 3 and k is equal to -3. Okay, so it just depends on you checking to see if your values or whatever answers you get fall within that particular range. Okay. Yeah. All right. So would you like me to do another question that looks similar to this one? What do you guys want me to do? Or is there a question you guys are stuck on? Should I do another one?
Can ma'am do another one, please?
Okay, awesome. Let me do another one. All right. So let us, this one was, this was sine. Okay, let's do a tan one. So again,
Ma'am, for cos,
yeah,
sorry. Ma'am, for cos, will it always be plus minus?
yes, for cos, it's always plus minus.
Okay.
Perfect.
Okay, thank you, ma'am.
All right. Then this one, 2 tan 3 theta minus 10 degrees plus 5 is equal to 0. Okay, now they want you to find the values of theta, which are between, yes, Cleo?
Hi, ma'am. I just wanted to say for everyone, if they want to find the general solution summaries, it's on page 246 in the textbook.
Thank you. Thanks, sweetheart. Okay. Right. Now, onto this one. First things first, okay? You want to isolate for theta. To start off, you're going to take the positive 5 over and you get negative 5. Okay. Like that. Then next step, you're multiplying by 2. So it's 2 tan theta. You're going to divide by 2. Minus 2 comma 5 there. The next step, inverse tan both sides, right? So when you inverse tan both sides, this is 3 theta minus 10 degrees equals inverse tan negative 2 comma 5 plus, remember for tan, your period is 180. Okay, so inverse tan negative 2 comma 5 minus 68 comma 20, sorry, degrees over there, plus 180K, 3 theta minus 10 degrees. Okay, so you were subtracting 10, inverse operations, you're going to add 10 to negative 68 comma 20. When you add 10, you end up with negative 58 comma 20 plus 180 degrees K. Okay, so you're left with your 3 theta this side, right? Last step, divide everything by 3. So theta here is now negative 19 comma, okay, my calculator says 40 plus your 60 degrees K. Okay. Any questions so far before I move on? Nope. Okay, cool. So, yes?
Never mind, ma'am.
Okay, cool. So if they had only asked you for the general solution, this is where you would stop. But for this question, they wanted us to find the actual values of theta within the range negative 180 to 180. Okay, so first things first, let's start off by substituting in K equals 0. So for tan, remember you only have one general solution. So let's sub in K equals 0. Negative 19,40 plus 60 multiplied by 0. So your first theta is going to be negative 19,40. Is it within your range? Okay. What do you guys think?
Yes, ma'am.
Right. So we're going to
Yes,
take that
ma'am.
answer. Perfect. Now let us try K is equal to 1. Okay. Negative 19,4 plus 60 multiplied by 1. I get theta being equal to 40,6 degrees. Is it within our range? Yes. Okay. Let's try K is equal to 2. So negative 19,4 plus 60 multiplied by 2.
Ma'am, I now asked this question already,
Mhm.
but with subbing in,
Yeah.
the way the general way we can always do it, like in steps, would it be 0, 1, 2, and then -1, -2?
Yeah, so you'll see here, I've gone up to 0, 1, 2. I'm going to try 3 as well to see if it works. At the point where it's not in my interval, then I'm going to go on to the negative values.
So we go on, so we sub in every time until it's out of the
range.
intervals.
Yes,
Okay, the
exactly.
range.
Okay.
Okay, so say maybe 3 is still in the range
Uh-huh.
and 4 is out, then we will have 3 and then we will start going from -1, -2.
Exactly. Exactly.
Okay.
Exactly. Good. So now we're testing the k is equal to 3. So 19,4 plus 60 multiplied by 3. Okay. I get 160,6. Is that within our range? It's still within our range, right? Okay, because it hasn't passed the 180 mark yet. So if I try k is equal to 4. Someone wanted to ask something? Okay, so when I try k is equal to 4, okay, I get 220,6. Okay, so now 220,6, is it still within the negative 180 to 180? It's not, right? So I'm going to discard that value. So I'm at the point where I can't find more values. So I found 4. I'm going to go now and try find k is equal to -1. Okay, so 60 multiplied by -1. I get -79,4. Is it within our range, -180 to 180? Yes. Okay. Now let's try k is equal to -2. I get -139,4. Is this within our range? Yes. So let's try k is equal to -3. I get -199,4. Is this value within your range of -180 to +180? No,